Hello everyone, welcome to Microcontroller and Embedded System Lab. In today's video, we shall discuss about the program number 3, write an program to find the factorial of a number. Okay, this is the code to find the factorial of a number. Again, area specifies area of your program, then factorial is the name of your program. We are writing code and we are reading only the memory locations. Now entry specifies first entry of our program. Here we are moving a value to register R1 whose factorial has to be found. Okay, here we are finding factorial of 5. We can change it to 7, 4, 5 as per your requirement. Which numbers factorial has to be found, that is stored in R0 value. Then first, before that, factorial is nothing but 5. If you want to find the factorial of 5, that is 5 into 4 into 3 into 2 into 1. This is 5 factorial. If you want to find 6 factorial, that is 6 into 5 into 4 into 3 into 2 into 1. So that is, if you want to find n factorial, that will be equal to n into n minus 1 into n minus 2 into n minus 3 till it reaches unit value. Okay, now we are considering example as 5. Okay, the same value is copied to register R1. Now after executing these two steps, R0 will be equal to 5 and value will also be equal to 5. Okay, this is the label, just ignore this. First subtract R1 comma with 1 value, that is we are having R1 is equal to 5. After subtraction, R1 will be equal to 4. Okay, we are subtracting 1 from 5. Then we are comparing this R1 with 1 value. So that is R1 value is equal to 1. We are having R1 is equal to 4. So R1 is not equal to 1. Therefore, if it is not equal, this line will not be executed. That is B equal to stop will not be executed. It will jump to next statement, that is multiply R3 comma R0 comma R1, that is R1 and R0 will be multiplied and it will be stored in R3 value. So R0 is equal to 5, R1 value is equal to 4, that is 4 is done, that is 20. It is stored in R3. After execution of this step, R3 will be equal to 20. The same value will be copied to R0, that is R0 will be equal to 20. So now branch not equal to fact. It will compare is our counter value or R0 value which is equal to 1. Then it is not equal, then it will move to fact. Here again, what is the value of R1 here? The R1 value is 4, which is subtracted by 1 and R1 value will be equal to 3 now. Okay, after that it is compared with 1, it is not equal to 1. It will go to multiplication step. Here R0 will be equal to 20. This 20 will be multiplied with 3. Okay, that will be equal to 60, which is stored in R3 and same value will be copied to 20. Okay, observe same procedure is following, that is first we are multiplying 5 into 4. The multiplied value will be equal to 20, which is then multiplied with 3. Then again it will go to label fact here and it will subtract, R1 is subtracted by 1 again, it will be equal to 2, which is multiplied to this 60. Again, the answer will be equal to 120. Now, R1 is subtracted by 1, that will be equal to 1. So, it is compared, R1 is equal to 1, then it will go to this branch. If branch equal to stop, our program execution will be stopped here, and the output value will be equal to 120. This 120 is in decimal, but in Keil it is stored in hexadecimal. Okay, let us see what is the value of 120 in hexadecimal. That is equal to 78. Okay, this should be our final answer. Okay, so now let us execute this code in Keil Microvision software. Now, before starting any project, we have to close our previous project, new Microvision project. Name it as program 3, save. Select a microcontroller, that is LPC2148, press OK, startup file, press no, then file new, write the program, then save it, with the extension .s. Save. Then we have to add the existing file to our source group. Select all files. Okay, now add the program to the existing file. Add, close. You can observe your program is present under our source group. Now build a program, 0 error, 0 warning. Then rebuild it. To observe the output, debug, start or stop, press OK. Okay, step by step execution is done. First we shall move the R0, 5 value to R0. Observe R0, it is having 5. Then we are copying the same value to register R1. Next, we have subtracted 1 from R1, that will be equal to 4, that is stored in R1. Okay, comparison is not shown in the register, it is done. Then multiplied value of R0 and R1 is stored in R3, that is equal to 14, that is hexadecimal value of your 20. Then again this value will be copied to R0, then R1 is subtracted by 1, then 14 into 3 is multiplied, that is stored in R3, that is same copied to R0. Okay, after complete execution, you can observe R0 is having value 78, that is hexadecimal equivalent of 120. This is a final answer which has to be stored in R0, that is nothing but factorial of 5. If you want to change this number or you have to find any other factorial, you have to stop our debugging, then you have to change this to some other number, that is you can find the factorial of your required number Okay, if I take the example of 6, factorial of 6 has to be found, that is 5 into 4 into 3 into 2 into 1, that is equal to 720. Okay, likewise you can find the factorial of 7, 8, 9, any integer you can find the factorial. This is our program number 3. This instruction means R0 will be having the value of, R1 will be having the value of number whose square has to be found out. If you consider 7 as our example, then R1 will be having 7 initially. Okay, so then R1 has to be copied with this whole result, that is R1 comma LSL hashtag 0x2. What does this means? It will be equal to R1 multiplied with LSL 0x2 means 2 to the power 2. If we have 3 here, then it will be 2 to the power 3. Okay, so we are writing here 2, so that therefore it will be equal to 2 square. Okay, this is nothing but the result of this 7 into 4. If we are considered R1 as 7, then after executing this instruction, R1 will be equal to 7 into 4. Okay, if you consider R1 as 8, then after executing this line, the result R1 will be equal to 8 into 4. Okay, let us observe this in our program. So first we are loading the initial address of our table to R0, that is initial address is 0x18. Okay, you can observe 0x18 has 0 in its memory location. Okay, then if you want, you can check for all the values. Okay, 18 in hexadecimal, 18 plus 4 is equal to 1c. At 1c I should have the square of 1. Next 1c plus 4, that is equal to 20. At 20 I should have the square of 2. Then 20 plus 4, that will be equal to 24. At 24 I will have the square of 3. At 28 I will have square of, sorry, here I have not changed, this is square of